Hey everyone, welcome to this week's episode of TGIF, run by yours truly, where we get together for good vibes on the ecosystem and also keep on tabs of what the many orders of the Covenants are up to. This week is very interesting because it's where we start to see the light at the end of the tunnel, or the light at the end of many consecutive tunnels. We finally took a checkpoint 2, which I believe is about a month old in the current run. And we pushed trained it a bit and we made an app. And we're gonna talk about it. So this is very interesting. So just to recap, our North Star has always been creating an end-to-end state-of-the-art model, homegrown on Bittensor. Because when we get this, it unlocks so many values. So what are we doing? We're pursuing the aim of continuing to work towards this sort of the art model. Along the way, we build technology that will be useful, and the aim is to productionize this technology. So it's like right now we're dog fooding things we need in building our own models. Eventually, we show this to the world. Everyone gets to use it, and we get to monetize that. At that stage, the model becomes a product, but also the platforms we use to develop these models are also valuable. There is a lot of value there. People say, why sell shovels? Why dig? You can either dig for gold or sell shovels. We say, no, we can do both of them. So we're digging for gold, which is sort of state of the art open weights model trained over the internet. But along the way, we have Sparse Loco, we have Grail, we have Templar's training mechanism, which we think is of significant value as we can convert the internet into a data center. And that crashes the cost of pre-training a lot and creates a new market. It's not that serious at this stage of the model because checkpoint 2 is trained on just 400 billion tokens. So it's a big model and a good model, but it's not at the stage where it's going to be anywhere near what SOTA is today. For us, what happened yesterday is once we released it, I vibe coded that chat template in about 30 minutes. So again, it's not, wow, this is massive template milestone, but for us, you start to realize what might become. And I think it's very cool to see a model and built end to end on Bittensor. It still has a lot of quirks. It hasn't been aligned or anything. But that is pretty, and I think that's pretty bullish for the ecosystem that we can do stuff like that. Now, moving on to the technologies involved, it's also showing the prophecy of Bittensor start to come true. That on its own is a collaboration across 3 teams. What Templar did is we did pre-training. You can talk to the base model if you want. So when you pre-train, you just say, this is a box. Let me just put all my knowledge in the box. You don't sort it. It has no idea of recall. It has no interfaces. So it doesn't know how to talk to you. So what Gradient essentially did is a very important part of push training called instruction fine-tuning, where you teach the model how to connect those dendrites in his brain. You say, if I ask you, this is how you respond, and you run it over and over again until the model knows how to talk to people. So, yeah, it's pretty interesting stuff. Another thing we also did is context extension. So, when we train the model, it can only return in our pre-training. We had to reduce the context, the sequence length. It means the model can only do 2,048 characters before it just flies up. So Gradient also extended this context length. Why is context length important? As you go to different levels of push training, you have things like chain of thoughts, where the model needs to be able to talk to itself, it needs to be able to reason. That's how you unlock reasoning. Now, with little context length, you can never get reasoning. The model has to think, okay, what day is it? Those are all tokens. If you want to get really long reasoning chains, one of the very important things to do is to be able to extend the context length. They've done that. So what we're going to be doing over the coming days or weeks is making sure that the Templar 1, I'm sorry, Covenant72B, that run is done well and it's going to finish at the end of the year. We are going to release an article about the next steps. It's probably working with a smaller model. Now that we've proven our infrastructure to be working, what we will prioritize next is, okay, how do we really gun for state-of-the-art model? Because I have this vision where models are produced on Templar. Templar is the factory. We work with Grails, we work with gradients for push training. Then we put them on Affine to Pareto dominates all of our finance environments, then that's how the model gets out to the world. We're not there yet, but having been able to talk to my model just says, wow, okay, this model is not Sutter yet, but I think that chat app is more like a mood board for me, more than it is a model. It's a model I'm going to be using every day, but hopefully soon. Yay! Hey, how's it going, buddy?
How about you?
I'm fantastic. Where are you? And what part of the world are you in?
I'm in Africa right now.
Okay, cool.
Yeah.
So I was telling guys how important the work you guys did is. So do you want to just give the room an overview of what you achieved with the post-training run, your challenges? Because I know there was loads of things. It wasn't something we could do internally. Yeah, so tell us about that.
Thank you. Yeah, basically, as you already explained, you guys gave us a model that pre-trained on text completion, which is one of the heaviest phases of SOTA models training. It's also the very first phase to have the backbone of the thinking model that will then be extended to respond to prompts, to align with preferences, to do reasoning, to answer coding or math questions. So we started with that. And as you mentioned, we extended its context using yarn, which is a rope method, and it operates on the keys and the intermediate layers of the transformers. It doesn't actually need any changing of the architecture. It's a simple mathematical technique that allows the model to understand more context without having duplications. We moved the model from a 2K context window into a 32K context window. And
Wow.
as you mentioned, yeah, and actually I'm looking at the paper right now, and they prove that even so the factor is times 16, what we did now, but they prove that you can go up to 32, and in some cases you can go up to x64 with some more. You might have some loss there. So we took the safest way, which is to multiply it by 16.
So let me just dumb it down. This was a very big step, what Gradence did here, because for us, we had to force that 72B onto 8 B200 machines. It took a lot of engineering. This meant we couldn't do a larger sequence length because we couldn't do a larger sequence length. So what these guys did is they took a little sequence length and blew it up so the model has more context without destroying its quality. For the geeks out there, this is pretty interesting.
As you say, the big win is that you don't need any engineering or more compute resources during training. It's just a mathematical technique. You apply it, and then you have a lot more context and can leverage your previous training to have the model continue its thought over larger context windows. This was one of the things we applied to the model. And then we also turned it into a chatbot assistant, basically, since pre-trained models are basically text completion models and they're not trained on conversations or multi-turn conversations. What we did here is that using the Jinja syntax, which is what basically most SOTA models do, we added these tags which say, okay, now it's the system message and it finishes here. Now it's the user message, it finishes here. And then there is the assistant message. When you do that, you are also able to turn it into a multi-turn conversation where you can have back and forth messages with the model, as opposed to giving it a chunk of text and then completing this text. So yeah, this is really the backbone, and it would affect greatly how the performance of the model. But then for having a true chatbot, you need to add this chat template. So we did that. That was the second step, basically. And then what we did is that we created a list of data sets that have had good results in their research papers, showing that they help models achieve good performance across benchmarks. We created these data sets, we merged them, and we also augmented a few of them with few-shot prompting using our own synthetic data generation pipeline. So basically, we had all this work which would generate one big data set that can be used to efficiently fine-tune a model. But this is not done in a single step. So once we have this big data set, we would divide it into lots of chunks given a target data set size. And then what we did is that we basically used Gradient, our platform, to send iterative sequential training jobs using the Templar base model augmented with Yarn and chat template. And after each training iteration completes, we would retrain